Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. My today's topic is the continuation of capacitor. In this particular lecture, we're going to calculate power in capacitor. We're going to show you how you calculate power in a capacitor. In my last couple of lectures, we basically came up with the voltage in a capacitor in terms of current. And then we also in one of my last lectures, we calculated current in terms of voltage. So just a quick recap. This is a capacitor right here, which we are working on right now. This is basically consists of two plates, okay? On one side, you have positive charge, and on the other plate, you have negative charge, okay? And in between this gap, you have insulation, dielectric. Insulation can be paper, plastic, glass, or any insulating material. So when we pass the current, basically charge accumulates over here, positive charge accumulates over here, which pushes the positive charge on this plate right here, and then all we are left with is negative. So you have positive charge accumulated over here, you have negative charge accumulated over here, and that basically gives you an electric charge or a voltage which you can store. So basically capacitor is a storage device. So that was a quick recap. Now everybody knows, all the engineering students know that power is equal to V into I, voltage into current. So we're going to use that and we're going to find out what's the energy per second, which is same as power in a capacitor. So let's see how. So if P is equal to VI, I can write this as P is equal to IV, same thing, okay? Then I know P is equal to, we know V, voltage, okay? Times, we know the current, we derived it last time in one of my last lectures. So it's going to be C times dV over dt. No rocket science over here. All I'm doing is that plugging in value of current in here, okay? So this is, you can say, this is power in terms of voltage. All right, no rocket science to that. So this is power in terms of voltage. And I'm going to go ahead and put this in a rectangular bracket so you can remember it. All right, now what we do is that we said P is equal to IV right here. Then I can say P is equal to I. We already calculated this in one of my last lecture. So we can say 1 over C, 0 to T, whatever time we are integrating it, I of T dt plus V of 0. What was the voltage at time 0? That's what it is right here, okay? Now we got that. So this is power in terms of current right here. Now you all know that power, and I think I went over this and explained that in detail. Power is basically energy over time, okay? And we can write this as d over dt. So rate of change of work over time, okay? So derivative of work with respect to time, all right? Now we can say P is equal to C times V dV over dt, right? Can I not do that? I already showed you right here. So this power, the whole thing is also equal to the rate of change of energy or work with respect to time. Pretty straightforward. So what we do is that we cancel these dt's right here, okay? And then what we have is we are left with dw is equal to cv d sub v. I'll just rearrange this equation right here, okay? And I got this. Now let me ask you this. I don't want derivative of work. I want the actual work. So what can I do to accomplish that? Well, the only solution is to take integral of both sides. When you take integral of this, you will be just left with W. And then on the right hand side, you will take integral of C, V, dV. Okay. All right. So when you take integral of this, you will get C times half V square. Okay. Or we can write this as work is equal to half CV square. So my friends, this is the energy stored in a capacitor. So now we have showed you in a capacitor voltage, how you know what is the equation for voltage. We've showed you what is the equation of power or work. We've shown you how you find current in a capacitor. So remember these, watch this video a couple of times before you walk into the exam rooms and solve some problems. All right, that's all I have for today. I'm going to come back with some more lectures. But till then, you take care of yourself. And if you like the contents, please go ahead and give me a like. Thank you so much.